So now that we have learned what a dot product is, it's time to learn how to use it. So let's say that I have vector v, which is 2i minus 3j, and vector w, which is 5i plus 3j. And I could start both of those vectors at some point in space, and it doesn't really matter where that point is. For vector v, it would be 2 to the right and 3 units down. So we would draw vector v. And for vector w, it would be 5 units to the right. So that's 1, 2, 3, 4, 5, and then 1, 2, 3. So there is vector w. The dot product can be used to find the angle between vector v and vector w. And the way that we go about doing that is using this formula. Cosine of theta is equal to v dot w divided by the magnitude of v times the magnitude of w. So if we take that value in the earlier video, we found that the v dot w product is equal to 1. We also know from last section that the magnitude of v is the square root of 13, and the magnitude of w is the square root of 34. So by plugging into the calculator, theta is equal to the inverse cosine of 1 over the square root of 13 times 34, we can find that the angle between vector v and w is 87.3 degrees. When we're writing answers in degrees, let's use 1 decimal place. When we're writing answers as numbers, let's use 2 or more. Now, the use of knowing that the measurement of the angle between two vectors is many applications. Just one of those is that we can determine if lines are either parallel or orthogonal. Okay, the word orthogonal is the replacement word for perpendicular when using vectors. So we use perpendicular when we're talking about lines or segments, but when we're talking about vectors, which is directed lines or segments, directed segments, then we are going to use the word orthogonal. This is going to become very handy when we move on to the next step, which is decomposition. We're going to do that in just a minute. But first we have to recognize when we are looking at two angles without working through the entire problem, there ought to be a way that we can determine if two vectors are either parallel or if they are orthogonal. So first of all, I want you to remember that the cosine of theta equals 1 or negative 1. So that's positive or negative 1 at what angles? That means that theta at 0 and pi would give an angle between two vectors of 1. Of 0 or 180 degrees. If the angle between two vectors is 0 or 180 degrees, then we know that they are parallel because the angles between them are either the same line, they're the same vector, they're just different magnitudes of the same vector, or they are in opposite directions. Either way, they're going to be parallel vectors. So if you are working through the formula above, where you have cosine of theta equals the dot product of v and w divided by the magnitude of v times the magnitude of w, and we end up with a value of either 1 or negative 1, then we know that we have parallel vectors. Another way to look at them and tell is if vector v is some scalar product of vector w. In other words, if it is an exact multiplier, vector w with an exact multiplier scale value of c gives you vector v, then you know that you have parallel vectors. A quick example of that would be if vector v was 3i minus j and vector w is 6i minus 2j. And if you recognize here that v, 2 times v, a scale factor of 2 times vector v is equal to w. Other than that, they're the same vector with just double the magnitude. It's going to be parallel. Therefore, If I were to follow through the formula, I would determine that theta is 0 or pi, meaning that these are parallel. Now, vectors that are orthogonal will have a dot product of 0. So anytime you have a dot product of 0, you know that the angle between them is 90 degrees. They're orthogonal. Now, I want you to think that through for just a second. If I were to find the dot product is 0, and then I did the cosine of theta equals 0 over the magnitudes, whatever those happen to be, right? The magnitudes, whatever they are, 0 over anything is 0. And the cosine of theta equals 0 whenever theta is pi over 2 or when theta is 3 pi over 2. Either way, it would be an angle of 90 degrees between the two vectors. And therefore, we know that if we get a dot product of 0, our vectors are said to be orthogonal. Now, looking at that, if I had two vectors that I wanted to make orthogonal, I wanted to make them be perpendicular. So I had vector v is I minus aj, and that's some random variable a. We're not sure what that's going to be. And vector w is 2i plus 5j. How could I show a value for a that creates orthogonal vectors between v and w? Well, if I know that the dot product has to be 0, then let me first of all find the dot product. Well, the dot product is a1 times a2 plus b1 times b2. So I'm going to do 1 times 2 plus negative a times 5. So that's 1 times 2 for the a values plus negative a times 5 for the b values. And I wanted that dot product to be 0. So I'm going to replace the dot product there with 0. 1 times 2 is 2. Negative a times 5 is minus 5a. And now I solve for a. By moving the 5a over and then dividing by 5, if a is 2/5, meaning if vector v was I minus 2/5 j, if a was 2/5, then vector v and vector w would be orthogonal.